Hello everyone. Today is March 7th, 2026, and it is a wonderful Saturday. I'm Sanno Annie, your friendly neighborhood radio host. And I am super excited to be here with you today. It is the weekend, so I hope you're all relaxing and having a great time. Today I am introducing a trending article from the archive, and it is a really fascinating piece of technology that I just have to share with you all. The title is Scribe plus a Scalable and Unified Audio-Visual Scene Understanding Model with Explicit Cooperation. The call is staps://arxiv.org/abs/3603.4128 AVUIE. It is long, but trust me, the content is absolutely mind-blowing. So, let us dive right into the details of what this paper is all about. You know how we humans can easily use our eyes and ears at the same time to understand what is going on around us. For example, if you hear a loud crash and see a vase on the floor, you immediately know what happened. We do this naturally. But teaching machines to do this is actually super difficult. Recently, scientists have been trying to build these massive artificial intelligence systems called audio-visual large language models. The goal is to create a single brain that can do a bunch of different tasks, like recognizing emotions, finding exactly where a sound is coming from in a video, even answering complex questions about a movie clip. But here's the big problem that this paper is trying to solve. When researchers tried to train these models to do many tasks all at once, they noticed something really weird and frustrating. It is called negative transfer. Basically, in nearly 55% of the tasks, the model actually performed worse when trying to line everything together compared to when it just focused on one single task at a time. Imagine trying to study for a math test and a history test at the exact same time, and you end up getting confused and doing poorly on both. That is what was happening to the artificial intelligence. The researchers figured out that this happens because of something called task heterogeneity. And, in simple terms, the tasks are just too different from each other. Some tasks require the model to look at tiny, specific details, like pointing out the exact pixel where a bird is singing. Other tasks are much broader, like understanding the overall mood of a conversation. When the artificial intelligence tries to use the same exact brain pathways for these completely different types of thinking, the pathways get tangled up and the model gets confused. This is called parameter interference. So how does Scribe Plus fix this huge mess? Well, researchers came up with brilliant solutions from two different angles, the data side and the model side. From the data side, they created a massive new dataset called AVUIE version 2. It contains around 222,000 examples across 17 different datasets. Instead of just giving the artificial intelligence the final answer, they added something called explicit reasoning processes. This means they wrote out step-by-step explanations for why an answer is correct. By seeing the reasoning steps, the model learns how to connect low-level details, like seeing the guitar, to high-level concepts, like knowing it is playing a happy tune. And on the model side, they completely redesigned how the artificial intelligence processes information. It created a unified input-output, which basically translates all these different tasks into a single language that the model can easily read. But the coolest part is something they call interaction-aware LoRa. Think of LoRa as tiny, specialized brain modules that attach to the main artificial intelligence. Instead of forcing the model to use the exact same modules for every single task, they built a smart router. This router acts like a traffic cop inside the artificial intelligence brain. When a new piece of information comes in, the traffic cop looks at it and says, "Okay, this is a question about locating the sound, so I will send you to module A." Or this is a question about emotions, so I will route you to module B. This dynamic routing stops the different tasks from fighting over the same brain space, completely eliminating the negative transfer problem. And for the results up, Crab Plus successfully reversed the negative trend, achieving positive transfer in nearly 88% of tasks. This means that by learning everything together with this smart routing system, the model actually became smarter at almost everything. Beating out specialized models that only know how to do one thing, when we compare this to older technologies, is a huge leap forward. Oh yeah, although multitask models would just mash all the data together and hope for the best, which usually resulted in a confused and underperforming system. But Crab Plus is organized, smart, and highly adaptable. Now, you might be wondering, how does this amazing technology actually affect our everyday lives? Well, I have prepared at least 3 specific application examples to show you just how impactful this could be in the real world. First of all, let's talk about smart home assistants for the elderly or disabled. Imagine a smart camera and speaker system installed in an older person's home. Right now, simple sensors might only detect a loud noise, which could be a drop book or a dangerous fall. But with a unified audio-visual model like Crab Plus, the system could hear a crash, see the visual footage of the person on the floor, and use its explicit reasoning to understand that an accident just happened. It could then automatically call for an ambulance and alert family members, because it understands both sight and sound promptly together, but would not make silly mistakes, making independent living so much safer for our loved ones. Secondly, think about the world of advanced video editing and media archiving. Content creators, movie studios, and news agencies have thousands of hours of video footage. Finding a specific clip is usually a nightmare that takes hours of manual searching. With Crab Plus, you could simply type a prompt into the computer like, find any exact moment where the man with the red hat starts playing the acoustic guitar on a busy street. The model can scan the video, listen for the specific sound of the acoustic guitar, visually identify the man with the red hat, and pinpoint the exact seconds the event occurs. This would revolutionize how we search, edit, and interact with massive libraries of video content, saving countless hours of work. Thirdly, this technology has huge implications for robotics and autonomous driving. Self-driving cars already use cameras to see the road, but driving is a highly audio-visual experience. Imagine a self-driving car navigating a busy city intersection. Suddenly an ambulance siren starts blaring. A normal car might struggle to know exactly where it is coming from just by looking. But a car equipped with a system similar to Crab Plus could hear the siren, visually scan the reflections or the distant flashing lights, and reason through the complex scene to understand that the ambulance is approaching from the blind spot on the left. It would then safely pull over to the side of the road. This ability to dynamically route information and reason through complex, messy real-world data could make robots and self-driving cars incredibly safe and reliable. Isn't that just so fascinating? It really feels like we're living in the future when we talk about these artificial intelligence models. Crab Plus has proven that machines can learn to understand the world, much like we do, by cooperating and organizing information smartly instead of just mushing it all together. Whoever in this deep dive into the archives is exciting as I did. Thank you so much for tuning in to my broadcast today. I am San Nolani, wishing you a beautiful and relaxing Saturday. Please take care of yourselves. Have fun this weekend, and I will catch you all next time. Bye-bye.